This video was produced by
Digital voltmeters are tools that help us measure various parameters of electrical circuits. In the engineering laboratories, you'll find two examples of digital multimeters that you will use in your laboratory assignments. These digital multimeters are very similar to other multimeters that you may find elsewhere. I'm going to show you the differences and the operational parameters for each of them when measuring four key electronics parameters: voltage, current, resistance, and continuity. The two different meters that we have are both developed by the Fluke Instrument Company, and one is called the 179, that's this larger instrument right here, and the other handheld multimeter that we have is the Fluke 115. They're both very similar in their operation. The only difference between the two of them primarily is, in addition to their cost, is their accuracy and precision. The Fluke 179 tends to measure voltages and currents and resistances a little more accurately than the 115. They're both very good instruments. Just keep in mind that the 179 is a little bit higher quality in the measurements, particularly when you're measuring current. So when I talk about making the current measurements, I'm going to focus more on the 179 because that's the one that I recommend that you use for making current measurements. Okay. A little bit more terminology. All of the multimeters have test leads to them. So these are the test leads that come in the bag for the 179 meter. And these are the test leads that are associated with the 115 meter. Something to keep in mind with the 179 meter is that they are interchangeable. So you can pull these test leads off. So if you're having trouble making measurements, something that you'll want to check is to make sure that there's a good connection between the cable and the test lead. Here, these test leads for the 115 are not separable, so you don't have to worry about that. The primary difference between measuring voltages and currents for both meters is the placement of the leads. So first thing I'm going to do is talk about measuring voltages. For both current and voltage measurements, we need to measure with respect to a particular test lead or port on the multimeters. For both of them, what I'm going to do is I'm going to plug in the black lead into the COM, or the common input port. So when we're measuring voltages, this will be the zero voltage reference, or the reference to which the other voltage measurements are made. It doesn't really matter that it's the black wire, that's just the convention that's made. The electrons don't care what color the wires are. But as convention, you want to put the black lead wire into the COM, or common port. Now, to measure voltages, we have to place the leads in a particular position on the multimeters. For the 179, to measure voltage, you want to put it in right above the COM port, or right beside the red input port that has the V beside it. On the 115, you want to put it to the right, the red terminal, the right red terminal right beside the COM port, which the common input port, which has the voltage or V symbol above it. Now, to measure voltages, once we have the leads configured properly, all we need to do is turn the dials on either meter to measure a voltage. Primarily, we're going to be interested in DC voltages, or direct current voltages. So to measure direct current voltages, we're going to turn the dial on the multimeter to the V setting to measure voltage, and to indicate that it's in DC mode, we're going to want to turn it to the V that has the solid line above it, the straight line above it. The V right here that has the squiggly line above it, that indicates that we're measuring an AC voltage, and that we're not going to be doing that as much in this course. So for this one, we're going to turn it here. Again, for the 115, we're going to turn it to the V with the straight line over top of it. So now both of these are in voltage measurement mode. Now what I'm going to do is use the meters to measure the voltage output of this power supply that is nominally set to 5 volts with respect to the building ground. To do that, with the 179, I'm going to gently pull back on the protective sheath around the lead, and I'm going to clip that onto my high voltage side. Notice that I'm not getting any measurement right now until I attach the low voltage side. Remember that we're making this measurement, and the multimeter is going to make the measurement with respect to the common input port, this black lead right here. So right now, since we put the common input port to the low side output of the power supply, we're measuring a potential difference of just a little bit over 5 volts. Now, if I had accidentally reversed that, if I had put the black lead on the high side output of the power supply, we would be measuring the voltage output of the power supply relative to the high side output of the power supply. In this case, we would measure negative 5 volts on our multimeter. To make this measurement with the 115, we perform a similar procedure. We can use the test leads and clip them on to our power supply output. And again, when we do that, we will measure a positive 5 volt output. When you want to measure the potential difference across an element in a circuit, it's the same thing. What I'm going to do now is I'm going to connect my 5 volts across this resistive element. And I'm going to use my test leads to measure the voltage across this resistive element. And your test leads need to be in parallel with the element that you are going to be testing the voltage across. So here I'm going to touch the 2 leads across the terminals of the resistor, and again I should measure about 5 volts of output across that resistor.